Hello!
Hello!
And welcome to day number 3 of
The PiHut Maker Advent Calendar.
12 projects of Codemas. So, we've been building up the project in this calendar, and today, day number 3, we've got Jonathan instead of Phoebe with us. Jonathan, today you're going to do the honours, so can you open the box? What's in the box?
Which side do I do?
That's
There you
it, yeah. And we've got an interesting design just before we discard the bottle. We've got another mini breadboard and some buttons. In him going click, click, click. And look, this box, again, another wonderful design. We've got what appear to be chips. We've got a, what's that? Is that music staves? No, that's just, oh, I see that. So some various electronic bits, and I just love these designs. They're so cool, don't you agree? They're too good to not keep. That's pretty cool, right?
Yep.
Right, we are back on the PiHut website, and let's hit day 3. Day 3, bashing buttons. Well, we get to bash them, at least click them. Don't want to bash them too hard. And okay, so welcome to day 3. We're going to do buttons that we're going to act as triggers to determine what happens. So we've got 1 mini bread button, 3 tall tactile buttons, some button caps, that's cool, and male-to-male jumper wires. Oh, the button caps are already on the buttons. Oh, I see. Oh, that's cool. So we already had LEDs. And if buttons are inputs and LEDs are outputs. Yes. So we're going to go and rig them in. We're going to wire them into GPIO pins, again, like we did for the LEDs, using the mini breadboard. So we got an extra control panel on the side. So we can have our main board over here, and we can control it from another board over here. That's cool. So important point here, make sure the Pico's disconnected from the computer. If your wire is connected, you might accidentally short something and damage the computer. Oof, you don't want to have power while you're wiring it. We don't want any magic produced smoke, so...
They could be good for Halloween, though.
Well, there are smoke emitting machines, but we don't want to turn the Pico into one, or my laptop. There's this central channel. Okay, so what we'll do is it disconnects one side of the buttons from the other, this central channel, whereas the breadboard is wired with lines that go this way. Guess who's actually going to wire this? Correct.
You might have to stretch them out a little bit.
How do you stretch them out?
You pop it in the hole and you stretch it across to the next hole. There we go.
Oh, okay. Won't that damage it?
You only do it very gently. So it's this way, not this way. So this way. So the long bit crosses the channel. That's it, yeah. So now you line up that bottom corner with the third one out there.
Yeah.
As we observed yesterday in our comedy sped up parts, electronics can be simple in terms of the actual understanding of design. It's just tricky in terms of it's fiddly. There's little tiny pieces. So if you move it by its base, there we go. Oh, that's in. So I'm stretching it sort of, do you see? And there we go, and it's in. And then we've got some wiring on this breadboard, Jonathan. You've got blue lanes, which are for ground or negative, and then the red lanes, which are normally for positive. We're going to connect a 3.3 volt line from the Pico out to that. You see where we've got this ground connection here on pin 3? Well, 2 pins across on number 5 is our 3 volt pins. So what we'll do is we've got a strip here, and because I'm going to stick with convention, I'm going to peel this so that the red line for our 3 volts, you're going to wire it from pin 5 there across to, do you see that top one up there? And I'll just put this in view.
Red one out. It's like here.
Is that on 5?
Yep, and the plus 5.
So it goes from 5 across to, oh no, not on the plus there, sorry, on 5 on the actual rows. You see here?
Oh, okay.
Ah, and that goes and jumps across to that top row.
Sweet. Up. Yeah. What's actually?
Oh, is it being a bit tricky?
Yeah.
Breadboard sometimes does this, where it just feels a bit stiff. Oh yeah, that's in. That's it. That's all the way in.
Okay, cool. Now you're going to wire in these 3 buttons. So
Yay.
take this and, well, you got 3 here.
Okay, this is satisfying.
Isn't it just? Each one goes to the bottom right leg of the buttons.
Kevin, why does this one have to be so tricky? Oh, there we go, finally. Let's see. I know.
This gets easier with practice. There you go. Yep. Next.
Oh, okay. I thought I heard something break.
No. It just found
wait,
its
no,
way in.
that broke.
Oh, right. Don't worry about that.
Oh.
It's easy.
What did happen?
Pop that in. Okay.
Whee.
Cool.
Goodbye. Where do I put this?
So you go for this next row here, still on the top line. The whole of the red line is connected anyway. So the top red line, this next, yep, that's it. Good. Okay, and you wire that into, again, yep, that's it. Yep, that looks like that's in. Okay.
Stick this one in.
Yep.
It's the same as the others.
Indeed.
How much
It's a little awkward.
battery?
It's black. There we go. It was brown.
How much battery would this take?
Not a lot.
Okay.
Now we've got to connect the other side of these buttons across to the GPI buttons. Okay. So we've got 13, 18, and 3. You do a bit of counting.
Oh, okay. It's a
1,
lot of
2,
wires.
3, and then put it in. So we start from the end.
So here?
Is that a gap of 3? That's a gap of 4. One more out. Yep, that's it from there. That's it. Good. Okay.
Yeah, it's a gap of
So
2.
That's it. So that's 3 because it's the end. And then push that into there. Perfect. And now the next one's a bit trickier. But look. So I tell you what makes the next one a bit less tricky. See this marking here, this white marking here? You can see the same white marking on the Pico. So you can use that white marking and go 2 across from that white marking. So 1, 2, and it's this pin here. Okay, right where my nail is, that particular pin that's in front of my nail, the pin you can see. That one, yep, that one. So wire it into the breadboard from there.
How do I wire it in?
You wire it into the breadboard next to it.
Is it here?
No. So these are, sorry, the breadboard is connected like this. So this pin out here will be connected to that. There's a piece of information Jonathan is missing. Breadboards are connected such that all of these pins are connected in lines, okay?
Yeah.
And if I say I want to connect to this pin here on the Pico, then I can wire it into this corresponding breadboard pin here. Does that make sense?
Yeah.
Cool, okay, and now you can put it into the button.
Here.
And then the last one, this one here, pin 5.
Hey, all these wires are in the way. I realised that.
And put it into this one.
Phone. No, not phone. It's something else, but I forgot.
Oh. It's not in the instructions, but I'm going to do one cheeky thing. So I'm going to use some spiral wrap, which might be overkill, but in this case, this will make this a lot nicer to work with. So spiral wrap, I use it on my robots all the time. And what you can do is you just wrap it around some cables like this when you've got a bundle of cables. Yes, it's simple, but it's fiddly.
Or eventually spiral out of control.
Well, the whole point is it doesn't spiral out of control with all your wires all over the place. Pros is it makes this tidy and nice bundle. Cons, and this is where I might regret doing it so early, is it's a little harder when you have to debug your wiring because it's a bit harder to see which things go where.
How's this cheeky again?
Cheeky because it's not in instructions.
That's just being creative.
True. Indeed it is. Being creative, it's using my tools in a way that makes it... And this is because young Jonathan here was complaining about, my goodness, there's too many cables and it's a bit of a mess. And I'm like, yep, so it is. Okay, I've got to trim that because it's a bit too much of the spiral wrap.
What are you going to do with that? It's a bit of a waste, you know? Can't use it.
Yes, I can.
Do you want to play with it?
Yeah, it's always fun to mess around
Okay.
with things.
If you want to play with that piece, be my guest.
Okay.
I think you'll all agree that makes that button just that little bit more easy to use, because now that whole cable can be just moved around without it unplugging things randomly from this end.
It is.
Activity 1 is a button test program. Okay, so in this activity, Jonathan, we're going to use the while loop, which you saw, we saw yesterday. You've kind of seen a while loop before, haven't you?
Yeah.
We're going to use if statements,
Scratch.
okay, which you've seen in Python and in Scratch, I guess. So we're going to do a code that basically says if the first button is pressed, light the red LED, pull downs. Okay, so the buttons are either on or off, but that means when they're not turned on, the GPIO pin is going to float. And that means it could be a logic 1 or a 0. Can you imagine doing an if when you can't tell when you've got a logic 1 or a 0, John? It means it's somewhere in the middle. Unknown. So this output pin, we're going to pull it down to ground. So when it's not connected to anything, ground is a logic 0. So our if will behave correctly. We're going to copy this into Thonny, not Johnny. And I'll save this as to the Raspberry Pi Pico as day 3 test buttons.py. We import the pin, which represents the actual pin on the Raspberry Pi Pico device, the machine. We've got a while true, so we're going to loop forever. We've got a time.sleep, just so we're going to wait a short delay, and it'll just tell us when button 1 is pressed. And John, if you press button 1, there we go, and it just says button 1 pressed. Do you see it? Do it again. That's button 2. No, we're only detecting button 1. But we could actually extend this to button 2. Before I jump the gun,
I'm going to get caught now pressing the button. I can no
push the button, that's what we're going to be doing. So that's button 1, multiple button inputs. We're going to change our if statement to do 3 buttons. Yay, okay, well let's copy that. It was kind of what I was going to do, but I thought I better check in case they've already done it. Okay, we're going to put this new code in, and how this new code is different is we're setting up 3 buttons. We're also in each button, you notice we're setting up pin pull down for each button, just to make sure it's pulling it down to ground. We're going into our loop, and it's checking each button and just saying which one's been pressed. And checking the button value equals 1. Yeah, making sure that it's set to a push value. Okay, go on then. You're absolutely desperate to press the button. Go on then, try them. So we should do button 1. Try button 1. And 3. What you'll also see, because this is something Thonny does that's cool.
Me holding the button works.
Yep, there we go.
Ooh, that is satisfying.
Okay.
Why are they making patterns? That is satisfying.
Well, it's just graphing 1, 2, 3.
1, 2, 3.
But you know what would be more satisfying? Because a graph is cool, but wouldn't it be even more cool if they were lighting up lights? Lighting up lights.
I get your point.
Let's light up lights. Okay?
I think I know where you're heading.
Good. So, multiple with if, elif, and else.
Ooh.
Okay, maybe we want to ignore buttons 2 and 3 if button 1 is pressed. Okay, so they're going to do if, elif, and else. Elif is else if. So I think in Scratch you used to an if block with an else block and an if block again. In Python you can do else if, elif. So this example here only lets you press 1 button. So currently, the code you've got, you can press all 3 buttons and it'll zap between all 3. Yeah?
It's kind of...
Look, there you go.
Can
So if you press all 3. But if we switch the code for the new code, okay, we can stop for a second then. Switch it for the new code and it will behave differently. And so the new code says that it'll check button 1 first, and only if it's not pressed will it check button 2. Do you see? So let's send this and now press the buttons again.
Okay.
And now if you hold down buttons, only 1's going. So only the lowest button takes precedence. Make sense?
Wait, the lowest button.
The lowest button wins because it checks it first in this cascading if. Look, if you look at the code right under your hand, it checks button 1 and it'll only look at button 2 if button 1 hasn't been pressed yet. Come on, I'm impatient. Where are we going to do the LEDs? So there we go. Look, this one's defining buttons and LEDs, and it's going to link which button is pressed with which LED it presses. Actually, it's going to do so 2 buttons and 2 LEDs. Okay, I can guarantee, like I did yesterday, that these colours will be off. Day 3, button LEDs 1.
Why do you need a file for this?
Both Donny and Mew make you save a file before you run your code. Right, we'll run this, and the amber, well, it says red here, but we've got amber. No buttons are pressed. Okay. Now, actually, one thing they're doing here, oh look, they're doing buttons and pressed. Look at that, it's detecting different numbers when you press them both. I
Yeah,
know.
and you need to press this one to be able to do the red one. You need to make green activate first before you could do red.
Oh, so hold on, let me try. Okay, so you got, oh. But look, if you then hold it, it stays on. Because it only goes off when they're all off. Okay.
Yeah, but you can't make them like go like Christmas lights, you know?
Ah, well.
There's a fun without Christmas lights. It's Christmas.
Of course. Maybe there's going to be Christmas lights shortly. Yeah, but this is funny because there's like a little unlock here, isn't there? So that was the example. This button or that button. So another trick we can use of buttons. We just did an and button, by the way. Did you notice that was an and? It was button 1 and button 2 if you wanted to light the green light. Now we're going to do button 1 or button 2. Do you understand and
Yeah, I
or?
was about to say, doing it all instead.
Oh, look, this is going to go blinky. Look, do you see? So it's got our time.sleep, so it's got a while true. 2 seconds. We're not going to wait 2 seconds. That's dull. Let's make it 0.2 seconds.
Okay.
That makes it a bit more Christmassy.
Button.
And if you press 1 or 2, it
Yeah, well, now
blinks.
green doesn't work.
No, because the code, I know it says green LED off and green LED on, but that's because actually the pin we've said is green is actually red because they're in different pins. As long as the
Also,
LEDs
Amber's staying on. Are you going to fix that, or was that intentional?
well, because this code didn't turn it off and the old code didn't turn it off. I get you. Well, what we could do is in here, I think we could say amber equals pin 18. Not too many equals. Right, and I could do amber. You see how we turned it off, John?
Mm-hmm.
Have a look at the code and tell you if you can tell me how to write turning it off.
The code's here, right?
Yep, you can use this code to guide you and this code to write it. How do we turn the green LED on?
Setting green value to 1.
Good. And how do we turn it off?
Setting it to 0.
We've got our amber pin.
Ooh, so just
Right.
turn it to 1.
So set the value. Press enter when you're done. There we go. You turned it off. You can see what will happen. Any value that's not 0 is considered truthy.
What does that mean?
That it's not false. So what you're finding is that any value that's non-zero makes it true. You've exposed something under about how it's been made.
I was thinking I could break it.
Yeah, I see. Glad you're experimenting though. That is the fun part. Okay.
Also known as trying to find ways to break it.
Toggling with buttons. Another handy feature we can use with GPIO pins is toggle. If you try the toggle call here, so on amber, and then press up to fetch it back and try it again. Swaps. This code picks up button 1, picks up an LED, and every time you press it, it toggles the LED. But they're going to say, look, day 3 complete. We're not going to complete on 1 LED and 1 button.
We need more.
Let's so not stop on there. So look, hold on.
What happens if the next day we need it to be like this or something?
We got 1 button, 1 LED. Let's send it. There we go. Try it now. So button 1. Oh.
Yeah, let's do this for all the others.
First thing is that delay is too long. 0.5 seconds. Come on. Let's make that 0.1. So it's a bit more responsive. Okay, hold on. Oh, that's too responsive, isn't it? Okay. Can we make that 0.3? But this isn't that much fun. We want to get all the buttons to do that, don't we?
Yeah.
Okay, right, what we'll do, let's go and grab from this day, look. So from the earlier button test, we're going to grab the other 2 button pins. So we have the other button pins. Yeah, because I can't remember what pin numbers those are on. Okay, hold on, device is busy. If you see device is busy, hit the stop button. But next thing I want to do is I'm going to load something from the Raspberry Pi Pico. We're going to take day 2 Blinky. So this is yesterday's Blinky. The right LEDs with the right colours. There we go. Do you want to be able to toggle each button individually, or do you want them to be linked in any way?
Nah.
Individually?
Yeah.
Well, how do you make it so button 2 toggles the amber? How are we toggling from button 1 to toggle the LED? And you do Command V to paste it.
Okay, I'm used to that being there, you know.
Ah, Windows laptop. Right, what do we change this one to?
Button 2.
And the LED?
Amber.
Yep.
That's just
For
odd.
good measure, we're going to change the text. Okay, so that should give you 2 buttons. Do you want to do the 3rd button? And
Wait, should I
green?
keep this value to 1 right here?
Yeah,
Okay.
because we're checking the value of the button when it's pressed. Remember, this is going to be 1 or 0, on or off, binary.
Scenario control V.
There we go. And make the last changes.
Wee.
Okay, do you want to send it then?
Okay. How do I send it?
Okay, you've sent it, and do the other buttons do their thing? Oh, do they all work? Oh, they're a toggle, remember? Hooray! Right, so we've got lights we can turn on or off by demand. So we've been through today's exercises, we reached the end of it. It's another case of let's leave the project assembled because we're going to build upon it. I hope you've enjoyed today's 3rd day of Codemas. It's Wednesday the 14th December. Hope you've had fun, I have. I think you can go make stuff and be awesome. Bye!
Bye.